if we're going to graph 5 30 degrees, then here's 30 degrees. We go out 1, 2, 3, 4, 5. Right. So, if I look at what I have here, if I'm thinking of this as my x and y axis, it looks like my x coordinate is somewhere between 4 and 5, right? And it looks like my y coordinate is probably somewhere between 2 and 3. But we can't really find exactly what that is just by looking at it. However, if we take the information we know that this side right here was 5, and we know this angle right here was 30 degrees. All right, we know those things. If I can find this distance right here, that would be my x coordinate. And if I can find this distance right here, that vertical distance, that would be my y coordinate. All right, so that would tell me go to the right x, go up whatever y is. So you should be seeing that that looks like a right triangle there. So we can use trig to solve this equation. So whenever we solve this, we've got 30 degrees here. It does not matter what you find first, x or y. Let's see, Luke, which one do you want to find first? Okay, so if we're finding x, is that my opposite, adjacent, or hypotenuse? Adjacent, right? And then I know the hypotenuse is 5, so that's the side I want to use. For adjacent and hypotenuse, which trig function do I use, Luke? Cosine. All right, so we'll have cosine of 30 degrees equals x over 5. All right, and then we just have to multiply both sides by 5. So x equals 5 cosine 30, which we are going to type into our calculator. And let's see, 5 cosine 30, we will get 4.330. That's our x coordinate. And that looks about right. It looks like it was somewhere between 4 and 5, right? So it looks about right. Okay. Christian, let's find y. So for y, is y my opposite, adjacent, or hypotenuse? It is my opposite. So if I could use opposite and adjacent since I know this side now, but I prefer to use the side that we don't have to round for. So if we're using opposite and hypotenuse, which trig function should we use, Christian? Sine. So we'd say sine of 30 degrees equals y over 5. And we'd multiply both sides by 5. And we get y equals 5 sine 30 degrees. And 5 sine 30 degrees is going to be 2.5. So our rectangular coordinates for this point are going to be 2.5 and 4.330. Oh, yeah. Sorry. Let's fix that. 4.330 and 2.5. I don't even know why I got this backwards. So if instead of going 30 degrees and having a radius of 5, I decide to go to the right 4.330 and up 2.5, that gets me to the same point there. Okay, questions? All right, now I am going to tell you a formula you can use as a shortcut. I usually draw them out. I'm bad at remembering formulas. But you may prefer the formula. The formula is definitely quicker at times. So, if I need to convert from my rectangular, from my polar to my rectangular coordinates, x will equal the radius times cosine of whatever your angle is. So x equals r cosine theta. And y equals r sine theta. I have a hard time remembering formulas, especially, like, you'll probably be okay right now. You'll probably be on the quiz if you study a little bit because you've just done it. But when you get to the final exam, if you haven't reviewed it lately, the likelihood you remember this is kind of low. But the likelihood that you could draw that triangle is probably a little bit higher because we remember the trig stuff there. So that's why I want to show you both ways. To help me remember the formula, because we'll need that for a few things. Like if I'm thinking of my point and I draw it out, this is my angle, this is my radius, and then here's my x, here's my y. I know that for this is opposite, so y is sine. This is my adjacent, so x is cosine there. So that helps me remember. Or you can just flat out just memorize those formulas there. Okay, questions? All right, let's do our next problem. All right, so this time we're going to convert -4, -pi over 4 to rectangular coordinates. And again, I'm going to do this two different ways. First, I'm just going to use the equation. So the equation told me that x equals the radius times the radius times the cosine of the angle. So I would have -4 cosine of -pi over 4. So if I get my calculator, now be careful. This may be a little tricky on the calculator. You're going to be switching back. Some of these are going to be in degrees. Some of them are going to be in radians. So you have to change your calculator from degrees to radians if you have a change in your graph there. So here I need to make sure I'm in radian mode for this one. And I'm going to do -4 cosine -pi over 4. And I'm going to get -2.828. And for y, I'll just do -4 and sine of -pi over 4. So -4 sine of -pi over 4. And here I get 2.828. So my answer would be -2.828. 2.828. Now let's graph this, first of all, to see if it looks right. And second of all, I'm going to show you the other way you could find this if you forgot the formula when you get to the exam. So if I graph -4, -pi over 4. So first of all, I need to find the direction. So -pi over 4 would be right here. Right? Because pi over 4 would be this far in this direction. So it would go that far in this direction here. This is -pi over 4. But I don't go towards -pi over 4. I go away from -pi over 4. So here I go 1, 2, 3, 4. So this would be my point, -4, -pi over 4. Now, if I were naming that point, I'd probably call it 4, positive 4, and then probably use 3 pi over 4, right? But they gave it to us this way. So if I go from the origin to that point, I know this right here is 4. Alright, and if I look at my x and y axis, I can see that coordinate probably does look like negative 2.8 and positive 2.8. It actually maybe looks a little high there. I did graph it right, though, didn't I? So it looks a little like it'd go above 3, but it's probably just the scale of the drawing here. So let's say we've already got the answer to this. If you remember the formula, that's the quickest way to do the problem. But let's say that we had forgotten the formula. I could make myself a right triangle here. So I'm going to make this part right here my x. I'll make this part right here my y. And I don't have it given to me, but what would the angle be right here? It'd be 45 degrees, right? Or pi over 4 if I want to stick with radians, but a lot of us like degrees better, so if I'm going to call that 45 degrees, just make sure if you're using 45 degrees that you have to be in degree mode in your calculator. So if I had forgotten the formula, the other way I could solve this is I could say that cosine of 45 degrees would equal, so cosine would be adjacent over hypotenuse, so adjacent is x over hypotenuse is 4, so I'd multiply both sides by 4, and x equals, if we type in, first of all, make sure you're in degree mode, 4 cosine 45. Okay, now notice I get 2.828 here, but it's positive. However, if I'm looking at this graph, I've just found the length of that side, right? But I know that if I'm giving coordinates, I've gone to the left that much, not to the right. So my coordinate would actually be negative whenever I put it into the answer there. So that's sort of the downfall of using the triangle. You're going to get positive answers for these, and you have to pay attention to where they're at. So this would be negative 2.828, even though you got a positive here when you solved it. And then to find the y, you would say sine of 45 degrees equals y over 4, multiply both sides by 4. So y would equal, and if you type that into the calculator, you'll get 2.828. Now this time it will be positive because you're going up 2.828. So you get the same answer. So formula is quicker, but you got to make sure you know the formula to be able to get the right answer there. Okay, questions? Drawn the triangle like here. You can. Just make sure that you label this x because that's your horizontal, and this one right here y, and you can do that as well. You're still going to get positives if you do that, so make sure you see that x is to the left so it is negative. But yes, it doesn't really matter there which way you decide to draw that. Okay, questions? All right. Okay, so let's look at this problem. This one, we're going to look at drawing it, but we're also going to look at just using the formula, right? This one is hard to graph because 230 degrees is not on my unit circle, right? Also, I've got 4.5 instead of a whole number. So this one's a little harder to graph, but still not that difficult to deal with. So 230 degrees is not on my unit circle. What's the closest thing that is on my unit circle? There's something closer than 210. 225. 225 is right here. All right, here's 180. If you add 45 to it, you get there 225. So 225 is right here. So 230 is going to be a little bit past that. Right, we're talking somewhere about right here. And then whenever we graph this point, it's 4.5. So if we go out 1, 2, 3, 4, I actually don't have my fifth circle. I think you guys do there. Yours have 6 circles on it. I think on those. Yeah. So I'm gonna go a little bit past 4, so about halfway between 4 and 5 there. Okay. So if I were wanting to draw this right here, I know this side is 4.5. And if I want to make this a right triangle, this side right here is X. This side right here is Y. Kind of made it a little off there. Okay, so I've got X and Y here. I know this side is 4.5. What you may want to do here is if you go ahead and think of your answers, what's the sign of your X going to be? Positive or negative? Negative. Right? What's the sign of your Y going to be? It's going to be negative. So I might go ahead and do that to begin with, because otherwise you might get your answer and forget to add that in. So if I am looking for X, this is adjacent and hypotenuse, so I would say cosine of X, or sorry, I need an angle. We don't have an angle. Oh, how can we find an angle? I knew this was good. I know the whole thing is 230, but if I subtract 180 from it, I can learn that this angle right here is 50 degrees. Because all the way around would be 250. 180 is that horizontal line right there. So if I subtract it, it leaves me this angle. So I would say cosine of 50 degrees equals X over 4.5. So I'd multiply both sides by 4.5. And 4.5 cosine 50. Is going to give me 2.893. But remember that needs to be negative because we're going to the left. And then for Y, I would say sine of 50 degrees equals Y over 4.5. Multiply both sides by 4.5 to solve. And 4.5 sine 50 is going to give us that our Y is 3.447. But that also will be negative. Now, I'm mostly teaching you this way because you may get to the test and forget the formula. But if you remember the formula, you don't have to do this. Hold on. I don't need that. I need this. Okay. So if you remember the formula for your X, you would have 4.5 cosine 230. Notice that gives you the negative. You don't have to worry about signs if you just use the formula. It is a little bit easier to do. And then for the Y, 4.5 sine 230. And we get negative 3.447. Questions? All right, let's look at what it looks like to go in the other direction. Okay, so you don't. I have put this graph over top of mine, which also makes it look a little messy, and it's also not quite perfect. But you can think of just taking those circles and putting these tick marks here. My grid doesn't line up perfect, but it's close enough. All right, so let's do the other way. So we're going to take our rectangular coordinates. Let me actually, here, I'm going to get rid of this for a second so you'll see. I'll put it back up in a second. So if we're just thinking of this, if we're graphing the point 2, 4, right, we would go to the right 2 and up 4. All right, that would end up being right here. So don't think of it as polar coordinates, just rectangular, right? So to the right 2 and up 4. Oh, I've messed up my coordinates here. Let's see if I can get them lined up again. Oh wait, I need to maximize there. Okay. That's pretty close right there. I'm not perfectly set up on my grid line, so I'm pretty close. So to graph that, I went to the right 2. I went up 4. All right. So if I need to find the radius there, what should I do? If I'm looking for the radius to make this polar, so this radius right here. Pythagorean theorem, right? This is a right triangle. Okay? So I would just say 2 squared plus 4 squared equals my C, or let's call it R, equals my R squared. So I'd have, say 4 plus 16, I'd get 20 equals R squared. Square root both sides. R equals, what do I get for that decimal? 4.47 for my radius. And that looks about right because it's somewhere between 4 and 5 on our graph, right? So it looks pretty close. And then, okay, any questions there? Then I need the angle. I need the theta here. So how would I find that? I cannot use law of sines because I don't have, well, I could use law of sines. If I use law of sines, I have to use the rounded value, but it would work. But let's just use regular trig so we don't have to use the rounded value. So 4 and 2, those aren't rounded at all. Okay, this is opposite, and this is adjacent. So I would say tangent of theta equals 4 over 2. And how do I solve that? How do I get rid of tangent? Inverse tangent. So theta is going to be inverse tangent of 4 over 2, or just 2 there. So inverse tangent of 4 over 2 is going to give us 63.435 degrees. So my answer for this would be 4.47 would be my radius, and 63.435 would be my angle. And that also looks about right, because right here would be 60 degrees, and it's a little bit past that. Okay, questions? All right. Okay, so we can also do this with a formula. Our formula for our radius is pretty simple. It's just x squared plus y squared equals your radius squared. You just do Pythagorean theorem with those numbers, right? It's not going to make a difference whether you use the negative or not, because Pythagorean theorem is going to square those numbers and get rid of it. Your angle is going to be, your angle equals inverse tangent of y over x. So you can do these with setting up the picture, or you can use these two formulas right here, which is pretty much what we used anyway. Right. So if we just use the formulas here, let's try just using the formulas and then we'll graph it to see if it looks right. We've got negative 3 squared plus 7 squared equals r squared. So that's going to give us 9 plus 49 equals r squared. So we get 58 equals our r squared, and our square root of 58, 7.616. Okay, and then our theta would be tangent inverse of y over x, which our y was 7, our x was negative 3. And if we do that in our calculator, tangent inverse of 7 over negative 3 is going to give us negative 66.801. Now, here is the limitation with that. Let's graph this. Okay. If we graph this, we would go to the left. Again, you're thinking like you've got, it's going to go off of my graph big time. I really need to, let's see. Let's move this down so I can actually graph this, I guess. And you may just want to look, because yours is probably going to, actually, you might be able to fit yours on a graph a little bit easier than I can, because your graph goes out longer. So if I graph this point, negative 3, 7, I'd go left 3, up 7, 1, 2, 3, 4, 5, 6, 7. I'd get this point right here. Okay, and if I draw in my radius here, we found that that was at, what was it, 7.616. That looks pretty reasonable, right? Look at the angle that I'm getting. I'm getting negative 66.801. Which quadrant would that be in, negative 66.801? It's in fourth quadrant over here, right? That does not look right for my angle. So this is the limitation to the formula. It will work correctly if you are in the first or the fourth quadrant. But if you are in second or third, it's going to give you trouble. So that's why I kind of like for you to draw the picture on these. So if you draw the picture here, this is x, this is y. We know this is your negative 3, this is your 7, right? So if you do tangent of this angle right here, tangent of theta equals 7 over 3. Ignore the negative there because you're dealing with a triangle and all sides of a triangle is positive. If you do inverse tangent of 7 over 3, you'll get inverse tangent of 7 over 3. You get the same angle, but it's positive, 66.801. Alright, this is 66.801. Alright, but that's not the angle that we want to give, because we want to give a unit circle value for our angle. We want to give this angle right here. So how could I find that? Subtract from 180. So if I do 180 minus that angle, I get 113.199. And that looks better. Alright, that is in the second quadrant. That looks like the right angle. So, especially if your graph if you're in the first or third quadrant, the calculator can usually handle doing those problems and you don't have to graph them. But if your polar coordinates are in the second or the third quadrant, if your rectangular coordinates are in the second or the third quadrant, go ahead and graph that because the angle is going to be off on those. To get 113, I know that this line right here is 180 degrees, right? That straight line across. And if this is 66.801, I just subtract it from 180 to find this angle I'm looking for here. Yes?
So, if we get it in the second and third quadrant, and we know what's going to happen, every problem that we have is in the second and third, we just flip the sign. So do it the same way we did the first
I think so. Another trick would be, if you don't flip the sign, if you just like add it to 180, it should work. So if it's in the second quadrant, you're probably going to get a negative. So 180 plus that negative will give you this. And then if it's in the third quadrant, you'll get a positive. So 180 plus that will give you that third quadrant value. So I think if you add it to 180, which I think just using the opposite sign will work for that. But just know, second or third quadrant, you can't go straight from the formula. It only works for the first and fourth. Now, the good thing is, though, for the other formulas, the first ones that I gave you to go from polar to rectangular, those formulas do work for the whole unit circle. They will work for the whole unit circle. You don't have to, for all the quadrants, you don't have to change those. Okay? All right, questions? All right. We are not going to get to the second part of the notes today, which means we will not take a quiz tomorrow. What we will do is we'll take it at the beginning of class on Wednesday. I'm probably going to put the quiz on Canvas. Most of the questions on it are multiple choice anyway, so I just have to change my graphs to multiple choice so that you, rather than graphing it by hand, you're just picking the graph that matches that point. So we'll take the quiz at the beginning of class on Wednesday. We'll still have our test Thursday, and since it's on Canvas, you'll be able to see your results from your quiz immediately. So I won't have to grade it by hand, so you'll get it back there. So your assignment for tonight is going to be page 572, 14 through 25. And remember, if you don't have a calculator at home, Desmos will do that inverse trig stuff for you if you need it to. So you can go to that Desmos calculator if you need that at home. So you got about 15 minutes right now. Go ahead and get started. Maybe you can get several of those done before you go. Yes? Friday's homework was page 558, 16 through 45. And you should still have some graphs left on those papers that I gave you. Just hold on to these notes. We'll do those tomorrow. If you think you're going to need some more of that graph paper,